Now this is exercise 12.9, question 7a on bearings. In this question we're told that a catamaran sailed 11 kilometres due south from P to Q. So I'll just mark that information in first. So we just start with our diagram. I'll just put where P is there. So P is this point here in the middle. So I'll just put a P there. And the catamaran has sailed south. So I'll just put that we're travelling south here in blue from P to Q. Okay, that information is marked in, and that distance travelled is 11 kilometres. So I've got that in on the diagram so far. We're also then told that the catamaran, so we're down here at Q, then the catamaran sailed 16 kilometres due east to R. So from Q we have to come across east to R, so I'll just put that in another colour, I'll just use green. So we're coming across from Q to R, 16 kilometres. Okay, we've got that. Now, of course, we've got a right angle in there, and I'll just put that in. Now, we're told to find the true bearing correct to the nearest degree of R from P. So before we can find any bearings of R from P, we need to draw a line between R and P. So I'll just put that in now. And we need to draw the bearing of, or find the true bearing of R from P. So I'm going to underline this from P. Okay, so I want it from P. So I start from P. I put a north sign and then I travel clockwise till I find the direction that R is on. So the angle that we're trying to find is this angle here. So I'll just mark that in. So I want to find this angle here. So that is the bearing or direction of R from P. Start from P, put a north sign, go clockwise until you find where R is. Now notice that this angle that we want to find is outside the triangle. Whenever we use trigonometry and we've got some side lengths here inside the triangle, we need to find this angle in here. I would find this angle in here because you want to find this arc marked there in blue. So if we find this angle in here, then this arc in blue will be 180 minus whatever this angle is in there. Now that angle in there in that triangle, I'm going to call it theta. So we need to work out what theta is. So we're going to use this right angle triangle here, and we're going to use tan. So tan of theta is 16 on 11. So I've just got the working out here for to work out what theta is. So we start with tan theta is 16 over 11. So therefore, to find the angle theta, it's tan to the minus 1 of 16 over 11. And when you do that on your calculator, you get that theta is 55.49 degrees. Now remember, this is a decimal at the moment. So 0.49 is just underneath 0.5. So it's closer to 55 degrees than 56 degrees. So therefore, theta is 55 degrees. Now, I'm just going to mark in what theta is on the diagram now, okay? So I'm just going to put that it's 55 degrees, so I'll just mark that in there, okay? So now we've just worked out that that's 55 degrees in there, so I need the bearing of R from P. Now, if this is 55 degrees in there, then this angle up here will be 180 minus 55, which is 125 degrees. So I'll just mark that angle in now. Sorry, that bearing in. So this bearing up here is 125 degrees. So I've done that. Sorry, just things are moving around a little bit here. And in part 2 of the question, we need the bearing of P from R. So we need to start from R. So I'm going to need to put a north sign there at R. So I've just put a north sign there at R. So I want the bearing of P from R. So again, we start from R, okay? And we have to go clockwise until we find that other direction. Okay, so I'm going to mark that in there with green. So I want the bearing of P from R. So I start from R, go north, go clockwise until I find P. So basically we want that angle marked in there. Now we have to see how we can find that angle there marked in green. So we know that this angle in here is 55 degrees. So because this is also a north sign there, so I'll just mark that in. Then because they're both north, as I said, those two lines with the arrows on them are parallel. So remember, with parallel lines, we can look at alternate, corresponding or co-interior. Generally with bearings problems, we will look at alternate angles, like Z angles, or we will look at co-interior angles. I think it'll be easier to do Z angles or alternate angles in this case. So if that angle in there is 55, then this angle over here is 55. So I'll just mark that in there. Okay, now we have to find this angle marked with the green arc from there all the way around there. Now remember, one full revolution all the way around is 360, so therefore this angle there marked in green will be 360 minus 55. Now 360 minus 55 is 305 degrees. So therefore the bearing of P from R is 305 degrees, and the bearing of R from P is 125 degrees. Now this is exercise 12.9, question 8A, which is also a bearings question. Now in this question, we're told that Martin walked from home, which is H, to the local store S on a bearing of 35 degrees. So we'll just start by putting in a north sign. He walked from home, so he started from H, so that's why we put a north sign at H, because that's where he started from. So he started from H, and he walked to the local store S on a bearing of 35. Now, bearings are measured from north clockwise, so roughly going clockwise from north, 35 degrees will be, up there somewhere. Now, it doesn't have to be exact, all right? So I'll just say that that's probably a little bit bigger than 35 degrees, but I won't worry about it. So this angle in here is 35 degrees. Of course, this is three figures here, 0, 3, 5, but on my diagram, I can just put it there as a normal 35 degrees with no 0 in front, okay? Just remember, if you're writing an answer as a bearing, you need three figures in your answer, but on the diagram, it wouldn't matter. Okay, from this position here from the local store, he then changes direction and walks on a bearing of 125 degrees to the park P. So because he's changed direction, we need another north sign so that he knows where he's going. Okay, so I'll put another north sign in there. He's then traveling on a bearing of 125 degrees. So we start from north, go clockwise, and 125 degrees will be, if I go this far, it's 90. And a little bit more gives me 125 degrees, so it'd be roughly down here. Now it says he walks on a bearing along here of 125 degrees to the park P. So he walks to the park P, but this park happens to be due east of his home. So I need to stop the walking once he's along this east line here. So I'll just put the east line in first. So there's my east line. So the park is due east of home, and he keeps walking from the shop to the park here, which happens to be due east of home. Now, of course, this will be a right angle because that's a northeast line. And I'll just put in the 450 meters in there. Now, in this question, we have to show that angle HSP is 90 degrees. The other thing I haven't marked in is this bearing of 125 degrees, so I'll mark that in now, because the bearing, so he walked on a bearing of 125 degrees to the park. So he's left S, so it's basically the bearing from S to the park is 125, so I've got that angle in there. So we have to work out what this angle HSP is. And we actually have to show that it's 90 degrees. Now, you'll just do this by using things like alternate angles. So I've got alternate angles there. Remember, we've got the two north signs. So those two lines there are parallel. We can do Z angles, like a backward Z. So this angle 35 in here equals this angle in there, which is 35. So I can just mark that in. Now, when it asks you to show that that angle is 90 degrees, you can just do it by drawing in the angles on the diagram, and you can just put like a little arrow to it, just saying, you know, alternate angles. We can see here that this angle here is 125 degrees. Now, if I draw an arc all the way around, remember there's 180 degrees in a straight line. So this little angle in here will be 180 minus 125, which is 55 degrees. So I'm going to mark that 55 in there. Okay, so that angle in there is 35. This angle in here is 55. And of course, we know that 35 plus 55 equals 90 degrees. So therefore, this angle in there is 90 degrees. So we've done part 1 of the question to show that angle HSP is 90 degrees. In part 2 of the question, we have to find the distance between Martin's home, which is H, and the store, S. So we need that distance along there. It would be a good idea to redraw the triangle. So I've just drawn that there. So we want this distance from home to the store. I'll call it distance D. Again, notice, look, we do know that this is 90 degrees up here, so I've marked that in there, but we need to find this angle down here. When you're doing trigonometry, this is right angle trigonometry, so we know we've got a right angle there, but if we've got an unknown side, we actually need to know another angle in the triangle. So we need to work out this angle here. Remember, northeast, this is east along here, that will be 90 degrees. So this angle in here will be 90 minus 35 degrees, which happens to be 55 degrees. So I've just marked that in here on this diagram that it's 55 degrees. Okay, so now by redrawing the diagram over here, you can clearly see you've got a right angle. We know that this distance down here is that distance there, which is 450 meters, and we can work out D. And we can use cos. So cos of 55 is adjacent over hypotenuse. So cos of 55 is D over 450, and you can just work out D then. And remember to round it off to 1 decimal place.